Hi everybody, welcome to the first of a two-part lesson where we're looking at non-parametric alternatives to a couple of the hypothesis tests that we ran earlier in the course. So if you remember back when we looked at the paired t-test and the independent samples t-test, among others, but these are the two we're looking at today, both of those had assumptions of normality that needed to be met. And we were able to wave those away sometimes if we had a large enough sample size. And that's true, that is still the case. But if that assumption has not been met, where we have more than a mild departure from normality, and we also don't have a large enough sample size, then we have to use a non-parametric test. Which is one that doesn't require that assumption. You may be wondering why we wouldn't just always go straight to this test if we don't have to worry about assumptions on it. If you remember back to the beginning of the course when we talked about power, the t-tests have higher power than the non-parametric alternatives. And what that means is that if there's a result there, if there's a difference between the groups or within the groups, the t-test is more likely to catch it than the non-parametric test. So let's look first at our first one. This is the non-parametric alternative to the paired t-test. So if you're going to run a paired t-test and you find that you don't have your assumptions met, this will be your plan B. And this is called the Wilcoxon signed rank test. The nice thing about the Wilcoxon signed rank test is that we don't have to test any assumptions, none whatsoever. So that's nice. Hypotheses, the big difference between the Wilcoxon signed rank test and the paired t-test, aside from not having the assumptions, is that here we're looking at the median rather than the mean. Okay, and that's actually true of both of the non-parametric tests we're looking at today. So the hypothesis here is that the median of the differences is 0 versus not equal to 0. We can run a one-tailed test as well, and we'll get to that. I'm not in these videos gonna show you the nitty-gritty of how these tests work, but they're kind of nice. So I will post YouTube videos where other people have done that, so that you can see it. All right, so let's look at our old familiar attention span data set. And let's compare the number of hours spent watching TV to the number of hours spent exercising. And this is a within subjects test because this is not two different groups. This is multiple measures on the same individuals. So this would, if we were doing a t-test, would be a paired t-test. So in SPSS, to get our output, we're going to go to Analyze, and this is down here under Non-Parametric Tests. It's tempting to use related samples, but I've tried that, and it doesn't give output that's as good as what's here under Legacy Dialogues. So under Legacy Dialogues, we are looking at 2 related samples. And we're just going to take our 2 variables, move them over. So number of hours per week spent watching TV, and number of hours per week spent exercising. And we want to make sure we've got a check mark next to Wilcoxon. And we'll click OK. And that's our output, which I've already copied over here. So in this output, some things we're going to need. We are going to need this right here, which is our sample size. So this is the number of pairs. This is ND, or just N. The important thing here, though, is this. This is your p-value. This right here is a z-value, which we're going to need. This is the test statistic, but we're going to need it in our effect size calculation. All right, so here's our p-value. This is for a two-tailed test. And if we want this to be run as a one-tailed test, we just need to divide that p-value by 2, just like always. To get our descriptive statistics, you can go to Explore, like we've always done. Do number of hours per week spent watching TV and exercising. Move that over. The other thing you can do that'll work this time, not for the second test we're going to run, but if you don't need quite as much information as for Explore, you can run it under descriptives. And you see I've already taken the 2 variables and moved them over. Click OK. We get just kind of an abbreviated descriptive statistics output. All right. And the reason we ran this was just to be able to talk about it in our write-up. The measure of effect size is called R, and it's just the absolute value of the test statistic divided by the square root of the sample size. So if we take our z value, negative 0.665, take the absolute value of it, divide by the square root of our sample size, which we said was 40. This gives us 0.1051. And I should put that this is a small effect rather than a moderate effect, because it is. So the guidelines here, with the usual caveat that these are very rough guidelines and you really should be paying more attention to the context in similar studies than to these guidelines, but here we get 0.1051, which is a small effect. Although typically if we fail to reject H0, I don't think it's that important that you state the effect size, but you can. All right, so here's our sample write-up. So we ran a Wilcoxon signed rank test to determine if there's a difference in the median amount of time adolescents spend watching TV versus exercising. It's our usual sentence explaining what we did. And then in the next sentence, we report our descriptive statistics. And then finally, the test did not show a statistically significant difference. And we got that as our p-value. And then I went ahead and stated the effect size, which you don't have to do if you fail to reject H0 again. So, all right, so that's really all there is to the Wilcoxon signed rank test. Stay tuned, and we will talk next about the Mann-Whitney U test.